All right, cool. Can you guys see this okay now? Probably. Okay, so let's go ahead and look at some map stuff. So I got a lot of stuff written on here. I'll clean this up for you guys. So the first thing we can go over is basically just what you need to have a map and the syntax of a map. So for instance, on line three, not three, line two, that's us just including the map. So this is going to be similar to a vector. You actually need that include statement. And then on line 6 through 8, that's actually defining what these maps are. We're actually initializing some type of map. So line 6, our map, the very first value, or I probably shouldn't say value, the very first item in this map is going to be the key, and the second is going to be the value. Okay, so these are how maps kind of operate. They're just a data structure of non-continuous memory where you have key and value pairs. Okay, so the leftmost item here is going to be the key. So all our keys in my map is going to be a string, and all of the values that are associated with the key are going to be an integer. And then similarly on line 8, a map of integer keys and integer values, and then 9 you have character keys and character values. You can have any type of pairing that you want, and you can put objects here as your values. If you use an object as a key, I don't know if it's going to recognize the differences between the objects for a key, but I know that you can have them for values. So let's go over an example of a couple things. So one of the things is that you can have duplicate keys and duplicate values. But I guess I should say you can't have duplicate keys. You can try to put duplicate keys, but it's not going to let you have duplicate keys. So really with the keys is if you try to emplace here, which is a map function, it's similar to push back with a vector. If you try to emplace this, it basically just will ignore this line. It won't do it because we already have a key called Trevor. These are very similar to like our Cartesian plane with x and y coordinates. If you look at it in the perspective of functions, a function is something that just has a one y value for every x value, right? So that's kind of how the keys operate. So you can only have one value for each key. So only one y value for each x key, right? X is the independent variable here. On the other hand, you can have duplicate values. So you can have one key or multiple keys rather, and then the same exact value. So if I change these all to 23, something like this is completely allowed because that would be similar to having like 4 different x values and all of them have the same y value, which is still considered a function, right? And even just thinking this in terms of programming, if you try to have multiple values with one key and then you try to print out what was at that key, I don't know what you would expect the system to do because it can only return one value. And if you've given it 10, it's not going to understand which one you actually want, right? So if we go ahead and make this, let's deal with just the duplicate keys for right now. I'll show you how that will work. So let's go ahead and make that. So what you can see is printed out is just 23 and 25. So I'm printing out the integer associated with Trevor and the integer associated with Brad. What you'll see is the first one is 23, even though we said it was 15 here. And that's because of what I went over where this is trying to be a duplicate key. And it will basically just ignore that. And place is going to ignore the fact that you're trying to do that. So that's something super important to know is if you're using the in place, it's not going to overwrite it. However, if you do something like this and directly access it without using the in place function, this will actually overwrite. This will actually overwrite that value. So that value will now be 24. So depending on how you're defining your system, if you want your map keys to be, or excuse me, your map values to be overwritten at a certain key, you can use a syntax on line 15. If you want to design your system in such a way that it does not overwrite any values associated with the key, you're going to use line 14. So you kind of have a choice here. Most of the time using functions, and we'll see this later, they'll give you a little bit more errors and feedback than using just the brackets. And you guys are probably familiar with this with vectors, where if you use the .at function and you access something out of bounds, it will tell you, it will actually throw an error and tell you you're out of bounds. If you try to access it with the brackets, it's just going to give you a seg fault, which is a little bit less helpful. So most of the time using functions are going to be more helpful. Any questions about duplicate keys? All right. So the next thing is duplicate values. And this isn't too bad. This is just going to, if I actually print these out, I guess I can get these and do that again. And get rid of all this stuff here. Okay. So with duplicate values, I'm just proving that this is going to be totally fine. All of these print out 23 when we print all of these out, and it doesn't give us any kind of weird output. And hopefully this just makes sense. It's not like we're trying to add multiple values to the same key. I think the easiest way, at least for me, is just to think of it like an actual function you'd find on a graph where if you see a straight vertical line, that would mean X has multiple Y values. That's just not going to be a function. So it's kind of the same thing here. Any questions on the duplicate values? That wasn't really a lot, but or any questions on the difference between the two and what is allowed and what's not? All right, cool. So let's go ahead and change some of these to some arbitrary numbers. And let's go ahead and instead of printing them out here, because most of the time if you have a data structure, you're not going to access things just like this. You're going to want some kind of loop, right? So let's go ahead and move this up here. Call it that. So my map. So basically, this is how we're going to end up iterating over a map. So in a vector, you can basically iterate over the size like you would for an array, where you access these things at I. So for a map, it's non-contiguous, so you can't really access things at the 0th, 1st, 2nd index, right? As you saw up here, it doesn't even have like a 0th index per se, because the key for my map is a string, not an integer. So actually, I'm kind of curious as just to what this will print out. I guess. I mean, nothing's in it right now, but let's put something in it. It might just print out. Okay, yeah, so it just absolutely crashes. Probably because we're trying to access it with these brackets. Again, the functions are going to help you out a little bit more. So if we did an at call similar to vector, let's see what it does here. This is basically just telling us like it's a logic error. Probably just because it doesn't even know how to handle that key that we gave it. Same thing here. So basically, if you try to access a map, from what I can tell here, if you try to access a map with a key value that isn't even the same data type, that will give you a issue. So we definitely can't access these things just at 0, meaning we can't just iterate through these normally, right? So we're going to have to iterate in a different way. So the way to do this is to create an iterator. So that is what line 24 is doing. My map.begin is going to create an iterator that is essentially pointing to the beginning of this list. And then we can create a for loop that is going to go until the iterator hits the end of the list. We can just do this by making the condition while iterator isn't equal to the end, and then incrementing the iterator with the plus plus. And then in 27 and 28, we print out the key and value by doing iterator and then 1st and 2nd. So you can see that iterator must be some kind of pointer, just because we're actually using the pointer arrow function, right, to actually dereference this to access the 1st and 2nd attribute. 1st meaning that's going to be the key. That's the first thing in this map value or map location. And then your 2nd is going to be the actual value. So if we run this, what you're going to see is it doesn't print out anything because I messed something up. Basically, there is nothing inside the map. So let's try that again. All right, cool. So we actually have stuff in the map. I didn't mean to print these out, but you can see that in here, I'm sorry, I want to do the other one. My bad, guys. Let's try this for the third time. Okay, there we go. So this is a little bit more intuitive. Basically, what we see here is it's looping through, and it's going to print out the key values and the or the keys and the values associated with that. So this is the best way to iterate over a map. This is just printing it out. Sometimes you'll want to do stuff with the keys. Other times you'll want to do stuff with the values. It all depends. Something that's important to notice is we emplace these in a different order than they put out, right? So basically what these maps in C++ are going to do is organize things alphabetically. So for here, you can see that the key value in the beginning is A, even though that's the last thing that we entered. And the next one's Brad, Kristen, and Trevor. So this is following alphabetical order based off the keys. Okay. So it doesn't care about what the values are. It's going to organize these things based off the keys, which makes the most sense because you're going to have, only one key, value, right? You can't have duplicate keys. So it makes the most sense to organize things based off of the keys. And most of the time, that's what people are thinking actually organizes these lists, right? That's their independent variable. So that's basically what happens with the iterator and how these maps are actually organized. Are there any questions about that? Okay. So the next thing is kind of following along on these lines, but it's basically just showing you how it organized something that is a integer. So if we use a different map and we have an integer and an integer, and then replace this because we're going to iterate over something else, make that. Basically, you can see that this, instead of alphabetically organizing these, it's just going to organize them starting at 0, right? So the 0th key is going to take priority over, 5, 10, 30. It's going to go from 0 up. This is an integer, so I'm curious as to what a negative value would be. I'd imagine that's going to be before the 0, but let's find out. Yep, cool. So it looks like it just starts at the most negative value and works its way up in terms of organizing these things. Another thing I wanted to show you guys is what would happen if you try to print out a key that doesn't exist. So basically, if you try to do my map and then .at, and then we know that Matt doesn't exist, right? We haven't set a key value that pairs with Matt. So if we run this, and I should print this out. It's basically going to give us a out of range error. So this is very similar to the vector, where basically it's saying like, hey man, like I don't know, what this value means. It just basically says like it can't find it, right? So this is helpful in the sense that the .at will actually throw some type of error. If you don't want an error thrown when there's just nothing, the other thing you can do is actually use the bracket operator. And if we make this, what it'll actually print out is for integers is just a 0 value. Okay, so this is referencing the key, meaning it's going to print out a 0 for the excuse me, this is representing the value rather. So this is going to basically print out a 0 for the value if the key doesn't exist. If we did this with a string, like made this, let's make this one a string, and we'll go ahead and comment this stuff out. Do my map character and then in place, what is it, a character, so it's just going to be T and then Trevor. And then if we try to basically print something out that doesn't exist using the bracket operators, so like A, for instance, what this will print out to us is just a empty string. So basically, the point I'm trying to make here is anytime you're trying to access something with the bracket operators and it doesn't exist, it's going to give you a blank of that item, meaning like if it's a string, it's going to give you an empty string. If it is a integer, it's going to give you a 0. If it is a character that's supposed to be printed out as a value, it's going to give you an empty character. It's basically going to be initialized to what makes the most sense, right? Zeros and nothing, meaning blank. So that's important to know. The reason before that this one was giving me an issue when I tried to access it at 0 is because the key type I was using didn't match a string. So if you remember, this actually threw an error when I tried to do my map brackets 0, and that's just because my map has a key value of a string. So it wasn't upset in the sense that it didn't have this element. It was upset because it didn't understand why I was passing it a key value that didn't match up with its key. So just to be clear on that. Any questions up to this point? Okay. Just taking a look at some notes here. Okay, so actually, I think that is probably about it for the maps. There's not a whole lot to it. I'm sure that they can get pretty confusing, but for the scope of this course, everything I went over is pretty much all you're going to have to know. Understanding that you can't have duplicate keys, you can have duplicate values, understanding what the behavior is when you try to make a duplicate value, definitely understanding what this syntax is, right? Which one is the key and which one is the value. Understanding definitely how to iterate over stuff. You'll need to know that. And then let's see what else. And then just understanding what happens when you try to access something that doesn't exist. So kind of all of the like basic behaviors of data structures, right? Just basically understanding how to make one, how to iterate over the data structure, and then how to add stuff to that data structure and then access stuff that does or doesn't exist. So kind of all those core principles are going to be all you need. You don't have to do anything too fancy. And then, like I said, the next lab, I believe, deals with the map. And then there is I think he went over it in his map lecture, if I'm not mistaken, when he talked about the sprites. That's something for project 3 that you guys would be able to use if you wanted to with maps. So that's pretty much where you're going to find that functionality. So yeah, that's all I had. So if there's no questions or anything like that, you guys have a good one. And then, like always, feel free to stick around if you need help with anything. So.